So I thought we would review Chapter 9 before we started anything new. You may or may not have your notes, and so in order to really progress, I'm just going to assume that nobody has their notes and they have to, I guess you could say, restart with their notes. So please make sure you're putting this in like a notebook or something so you can keep everything together. And if we do come back, I would like to see that notebook. So just assume that we are going to come back together. And that I will eventually see these notes, so just hold on to them. I have also posted the notes online if you prefer taking them like on paper and stuff, but really you don't have to print it off. You can just sort of use it as reference material, and you can just put this down on a scrap sheet of paper. And the same thing goes for your homework. You don't have to print anything off. You just have to hold on to your work and label it, obviously, with whatever it's titled, which it'll usually be what we've been doing, like 9.1, 9.2. And then you won't have to fill out the page number or anything, but you will have to say number 1, and you don't have to write the question, but you might have to put some work of some sort. So again, you don't have to really print anything out. The only thing I do recommend you print out is actually not even on this section. It's in Teams. So if you go to Teams, this is what should pop up, what should look like for you. If you go to the very top, you see files right there. And actually, I'll do it like this so you can see it a little bit better. But here's files right here at the very top. And we're going to go ahead and click that. And I already have a couple of things up here for you. And it might take a couple of seconds to load. I've noticed that with the assignments and stuff, it just takes a couple of seconds. So if you don't see it immediately, just wait. And if you have to, refresh after like 2 or 3 minutes. But now that we have all these items, we waited a couple of seconds. We actually see all of these PDFs that I've uploaded, which are all of your scores. So you have your T-score, you have your chi-squared scores, you have your negative z-scores, and your positive z-scores. So you can open these up, and you can, I recommend printing them off. Print them off, and you can use this as the back of your textbook. If you already have your textbook, it's not a huge deal, but for those of you who don't, again, I'm assuming that nobody has their textbook, and so that's why we're doing it this way. So let's do that review. The first thing you need to sort of recall is the formula that we used for this section. We used the formula z is equal to the difference of sample averages minus the difference of population averages, all of that over the square root of, and I'll put that square root in a second, o sub 1 squared over n squared at n squared n sub 1 plus o sub 2 squared over n sub 2. All right, there we go. And again, remember, all of these things mean something. This is obviously going to be our averages, or our means, it might be better, our means from the sample. All right, so that's that first little bit. The next thing that we see, which is off to the side, is our averages, or our means from the population. All right, and typically they don't give you this, so you need to remember that this is going to be typically 0. Typically 0. All right. Underneath that are O sub stuff. This right here, these are our standard deviations. These are our standard deviations. And it's important to know that not only are they our standard deviations, but they're from the population. And it'll say either the word standard deviation of the population, or it'll have these symbols. So those are the things you're looking out for. The final thing you need to sort of know from this section are the confidence intervals. The confidence intervals come from your differences in your sample means, and then added or subtracted with the z-score times our square root of sigma sub 1 squared over n sub 1 plus sigma sub 2 squared over n sub 2. All right, and again, the same numbers are still being plugged in here. The only thing that isn't is that means of the population. So that's just a quick little review of the formulas in and of themselves. So let's look at a quick example. So here's an example that we've actually done before. It says a study using 2 random samples of 35 people each found the average amount of time those in the age group of 26 to 35 years spent per week on leisure activities was 39.6 hours, and those in the age group above them, 46 to 55, spent on average 35.4 hours. Assume that the population standard deviation of those in the first group was 6.3 hours, and the second group found by previous studies was 5.8 hours. At alpha equals 0.05, can it be concluded that there is a significant difference in the average times each group spends on leisure activities? All right, so from the very beginning, we can automatically highlight a couple of things just to get us started. They tell us about our sample size. Our sample size is 35 for both of these, okay? So if you want to put maybe off to the side, you can write that N1, the first sample size is 35, but so is the other sample size. And sub 2 equals 35. All right, and then the next piece that we have is, we have this group, and it says 25 to 35, but that's not really relevant. That's just more of a descriptor. They do tell us that this group does have an average of 39.6 hours. So maybe off to the side, I can put next to this is one of my averages. It's my first one that they give me, so I'm just going to put an X1 there. I can keep going. Again, the next age group is 46 to 55. Not exactly important, so I'm just going to ignore that and go to where it talks about my average time spent. So this will be my X bar sub 2. Assume that this population standard deviation, okay, so there's that word, population standard deviation. So I know I have to use the formula I talked about earlier because it says my standard deviation and it's the population. So I can, again, off to the side of these numbers that I highlight, I can put, this is my standard deviation of the first one. But please make sure that when you're using this, anytime you have a standard deviation, you need to square it. If it's a variance, then you can just plug it in as is. But if it's a standard deviation, you do have to square it. So just make sure you remember that. The next one that they give me is 5.8. And you'll find that this happens often, that as you're doing this, whatever they give you in order, that's how you're going to plug it in order. So that's why in my first one, I put sigma sub 1, not sigma sub 2. is the first one they gave me, so I'm going to put a 1 with that. All right, so now I have pretty much everything. The last thing I really need is that alpha, and now I can go through my steps. The first thing I have to do is write my hypotheses. The null hypothesis is when they are always equal. So we're talking about averages, so I'm going to say my first average is equivalent to my second average. And then my alternative hypothesis comes from usually the last statement or maybe the first statement. So if I keep reading, it actually looks like it's in my last statement because it says, can it be concluded? Remember, the hypotheses are what we're trying to prove. Can it be concluded that there is a significant difference in the average times each group spends on leisure activities? And it doesn't specify greater than or less than. So because it doesn't specify, I'm going to go ahead and use the does not equal to. So just remember that when you see the word difference, typically that's going to be the does not equal to symbol. And since this is what I'm trying to prove, this becomes my claim. So I'm going to go ahead and just star that. All right, now that I'm done with my hypotheses, I can move on to the next piece, which is to find my critical values. Remember, critical values come from your alpha. My alpha is 0.05, and because it is a does not equal, that means it's a two-tail, so I need to take that amount and divide it by 2, and that'll give me 0.025. All right, so to find the critical value, you need to take this value right here and go to the Z table. And we know we had to go to the Z table because they give me the population standard deviation. If it was something different, we would go to the T table or maybe the chi-square table, but because we're talking about the population, we get to use the Z table. So let's go to that. All right, if we're using our teams, we would come here and we would click on the amount, we would click on the files at the top right-hand corner, and we would go into this PDF, which you can download and print, but we're looking for 0.025 in the group. So I see, let's see, that's 0.17, so 0.217. I'm looking for 0.25, so it looks like it's going to be somewhere here, 0.0256, 0.251. Okay, so this is the one that I want. I'm going to go ahead and circle it. If I can. There we go. All right, and so I can go off to the side and get my scores. I have a negative 1.96, and because it is a two-tail, I can make this symmetrical and make it positive or negative 1.96. So I'm going to go back to my other screen and write that there. All right, so I can write that this is going to be positive or negative 1.96. Now that I have my critical value, I can plug in all my pieces into my formula to get my test value. All right, and really before I actually do that, I am going to draw my picture really fast, because I've noticed that sometimes we struggle with is the test value your critical region or is your critical value? So when you get your critical value, that is what determines where you shade and where you don't shade. So remember, 0 is always in the middle, and so we can have positive 1.96 off to the right, and then that means that anything beyond that is going to be shaded in. Okay, and then we also have negative 1.96, and again, anything beyond that or behind that we need to shade in. So now we have separated our critical region. Then we go and plug it into our formula. Remember, that formula is very long and complicated, so I'm not going to rewrite it. I'm just going to go ahead and start plugging in. So it's going to say Z equals, all right, our first average, 39.6 minus 35.4, all of that over the square root of 6.3 squared. Remember, if it's a standard deviation, you have to square it. If it's variance, you can plug it in as is. Over 35, that is our sample size, plus 5.8 squared over 35, okay? And it's the standard deviation for all of that, and I'm going to go to our calculator to plug all this in. All right, and if you don't have this type of calculator at home, remember you can download that app that I mentioned. I think it's called Graphing Calculator TIX84, something like that. It's in the Teams thing. I went ahead and put a link for you of what you were supposed to, where you were supposed to go to get that. So hopefully you guys can download that app, no problem. But let's go ahead and set up our fraction. At the top, we had that 39.6 minus 35.4. Underneath that, we had the square root. And then we had two fractions here, so let me set that up first. All right, plus, and then another fraction. All right, so now that that's all set up, I can go ahead and use my cursor to start plugging things in. 6.3 squared over 35, and then 5.8 squared over 35. Press enter and we get 2.90. All right, so 2.90 was our number, and I'm going to keep it the same number of decimals as whatever my critical value is. So I have 2 decimal places in my critical value, so I'll have 2 decimal places in my Z, or my test value. All right, so I'm going to change the color so that I can sort of see, and I'll make it red so it'll be, I don't know, really obvious. Again, if we're starting at 0 in the middle and we have 2.90, that's positive, it means it's to the right. We just have to ask ourselves, is it farther than 1.96 or is it less than 1.96? And that's actually more than, it's a little bit farther, so I'm going to put it right here, 2.90. That's my test value, and I can see that that test value is in my critical region. And if it's ever in the shaded critical region, we know we need to reject it. And so if we were to sort of draw our box to make our statements, we would only be looking at our alternative hypothesis, so we can cross out the left two, and we decided to reject, so it'll be that top right-hand statement, which should say there is enough evidence to support the claim, whatever the claim may be. All right, so that is how we do that. The next example will be for our critical values, or not our critical values, but our confidence intervals. So this one says find the 95% confidence interval for the difference between the means, and it's asking for the previous problem's information. So remember the pieces that we had our, let me change the color. We had our first not sample size, but our first average, which was 39.6. We had our second average, which was 35.4. We have technically already found our z-score, or not our z-score, but our critical value, and we already took alpha and divided it by 2, so we can just use it as is. If it was a one-tail, we would actually have to redo some of this work again, because whenever you're doing confidence intervals, you have to divide your alpha by 2. We've already done that, so our z alpha sub 2 is going to equal positive and negative 1.96. And then, of course, we, from our previous piece, have our standard deviation. Our first one was 6.3. Our second one was 5.8, and our sample size was 35. So now that we have all of that, we can just plug it into our formula. Remember, that formula is as follows: plus or minus our critical value plus the second piece of that. All right, so we have all of that. We're just going to plug it in now. So this should say 39.6, minus 35.4 plus or minus 1.96 square root of 6.3 squared over 35 plus 5.8 squared over 35. And then we can use a calculator and get our answers. All right, so here is our calculator. I'm going to use the parentheses for the first piece, 39.6 minus 35.4, and we'll do our subtraction first. We'll find our smaller amount first, 1.96 times the square root of, and get these fractions back in here, plus, all right, and then we just need to fill in all these pieces. These pieces are 6.3 squared over 35, and again 5.8 squared over 35. Enter, and we get 1.36. All right, and we can do the same thing again. Instead of typing all of this out, I can do second, and then down here at the bottom we have entry. It says enter, but in blue it says entry. So I'm going to press entry, and I'm going to go back. I'm going to use my cursor and just move it backwards and change that minus sign into a plus sign. So that way I don't have to retype everything. So it looks like this goes between 1.36 and 7.04. All right, so I'm going to write that down and my other screen. All right, so my confidence interval should be between 1.36 and 7.04. All right, and so the whole purpose of this is if your confidence interval contains 0, we don't reject the claim. But if our confidence interval doesn't contain 0, we reject our claim. All right, so this is just an alternative way of deciding, are we going to reject or are we going to keep our claim? So that's the whole purpose of this. We can look at our confidence interval. It's between about 1 and 7. It does not contain our 0, so therefore we would have to reject the claim, which is matching what we did in our previous problem, where we did reject it because 2.09 was bigger than 1.96, or 2.90, I think. Anyway, so that is a review over 9.1. Please look out for my videos for the next couple sections. Hope this helps.